Hello guys, in another episode in Road2data. This time we're gonna discover together and have a very fast introduction into the world of big data and noSQL. In recent years, companies have collected a huge amount of data. This data has several characteristics. To just cite few, we talk about the three V's: volume, variety, velocity, but actually there's many other V's. Maybe we will have the chance to discover them later on, but the main three actually are the volume, variety, and velocity. Today we talk about like huge amount of data. We hear about like terabytes, petabytes, and zettabytes even in the case of big companies such as like Google. There is also variety. The data is coming from different sources as well as in different formats: text, video, audio, etc. And there is also velocity, which is like the speed with which the data comes actually and is received. So all these characteristics and features make it very challenging actually to deal with this data, especially using traditional data management tools. So the answer to these different problems has given the birth of the era of big data. And in short, we can define big data as a solution to handle storage as well as processing of large amount of data, especially in a distributed way. As a result, the emergence of different technologies. So, one of the solutions related to the big data problems, and one that everyone who is interested in big data, or maybe a profile as a data engineer, should be not only aware but like needs to have a decent knowledge, and why not even master certain basic components, and that is the Hadoop ecosystem. The Hadoop ecosystem actually provides many solutions in matter of storage as well as processing, and we talk about an ecosystem. That is because we have actually many projects, Apache projects. There is MapReduce, there is Spark for like in-memory processing. MapReduce is more for batch processing. There is Kafka for streaming, Hive like for like SQL like processing, querying of data. There is Mahout and Spark ML which are like libraries for machine learning. There is Pig, which is like enables you to do the same as MapReduce but using like a scripting language called Latin Pig. Pig Latin, sorry. There is Lucene and Solar, which are like searching engines, and OZ for scheduling, for instance, Ashbase, which is a noSQL database, Zookeeper for the management of these different projects, etc. So all these components actually work together in order to provide like a very efficient ecosystem to manage your big data. So as for storage, we're gonna talk about noSQL, not only SQL. Why noSQL? If you are familiar with the relational database, which are like the traditional ones, they are actually queried by using SQL, structured query language. The issue is that like in front of the huge amount of data, this type of databases started actually to suffer from performance issues, which gave birth to the noSQL databases, which manage the data actually in a distributed way. And this type of data actually of databases can divide it into four big families. Let's say there is the key value stores, which stores data as a key value, as the name like explain it. An example is the Redis database. There is wide column storage such as Cassandra, where the data actually is stored together as columns instead of rows. There is document databases, which is like a generalization of key value stores, because the value here is a much more complex data structure known as a document. And a very good example is MongoDB. And finally, there is graph databases, which stores data as networks, and an example is Neo4j. The question is, like, if you are interested in NoSQL, a very good starting point would be MongoDB actually. So go check what MongoDB looks like and how to work with it. The other question is that, like, as you can see, like here we have many databases, NoSQL databases, React, Cassandra, MongoDB, Redis, etc. So the question is how to choose the right one. And actually the answer is it depends on the problem you are trying to solve. However, there's like a very known theorem called the CAP theorem, which is defined as which states the fact that it is impossible for a distributed data storage solution to simultaneously provide more than 2 out of the following 3 guarantees. There is consistency, availability, and partition tolerance. In short, none of these different NoSQL databases can actually guarantee these 3 properties at the same time. So, in other words, in your case, you will see which are the 2 more important properties among these trees, and depending on that, you will see like the subset of NoSQL databases that respects those 2 guarantees that are much more important for you. So as you can see in the next graph, if you want to have like consistency and availability, then you should go for like green plum, Aster data, for instance. If you want availability and partition tolerance, then it's more like Cassandra, CouchDB, etc. So I hope you got the idea. And as for processing, actually there's many solutions. Like, we're gonna start by the basic one, which is MapReduce, and that we presented very quickly before in the Hadoop ecosystem. The idea about MapReduce, this first actually just concern like batch data, processing data in batch, not in streaming, not in memory. So you have a bunch of data of files in your like Hive database, for instance, in your HDFS, sorry, and you want to process it. So there will be like a certain mapping at first, where your input will be split into like different parts, and behind you can imagine that like these parts actually can go to different nodes, to different computation units. And once the mapping is done, there is actually several steps behind that are done, for instance like sorting, shuffling, etc. And then there is actually the reducing, which can be applied to the data in order to have finally the results that we want. This is the word count processing example. It's like the hello world of big data, and we will get the chance to go more in details for this example. Then we have actually one of the hottest big data solutions today, which is Apache Spark. Apache Spark actually started as a in-memory processing solution, but it has like also, it's a very good solution also for batch and streaming and machine learning and graph also. So like this project actually is amazing, and there is like certain concepts that you have to try to understand, such as like RDDs, data frames, data sets, partitions, etc. and there is like the Databricks, which is like the startup behind the Spark project. And here actually there is this community cloud databricks.com, which is actually kind of notebooks that that are provided by Databricks, which enables you actually to go and start learning Spark without worrying about like the architecture behind. So this is the community cloud Databricks solution. You can sign up if you already have an account. Then you just like sign in, put your email or username and password. So once you log in, actually this is like the Databricks notebook solution in some sense. Like you can create notebooks, upload data, create table, etc. Here you can have like your recent notebooks. This is like a notebook that I've got like out of like one of their presentations at Databricks, where you can actually load data from file system. This is just like just to check actually the link, but like here you can have like your Spark session, read the CSV file for instance, load your like PySpark libraries, etc. Define the data structure. Here you have your data frame for instance. You can take a look into the columns, the row count, etc. So it's very useful actually to work with notebooks. And here is like a very basic column selection. For instance, I'm gonna go a little bit toward the end. Oops. Yes, I believe this is it. So here you can even actually get the result and show it in form of like of charts. You have a lot of the different type of charts, etc. So this is for like the Databricks solution. Otherwise, and it's a very good one actually if you want to just get started, because behind actually you have a cluster that is running for free, yet it's limited in power. And we have a demo. Let's go. We're gonna use intellij IDEA as an IDE. The project will be an SBT project, and we're gonna use Spark 2.11. So let's go. So here is our Spark application. This is an SBT file. So we're gonna go and see our build.sbt. It's one of the most important files in the project, where actually you define the dependencies to your project and application. So here we are importing Spark Core, SQL, and Hive, and the IDE will take charge in order to download these packages. Then in my source main folder I have two folders: resources, where I'm gonna put like my files. Here this is like a titanic.csv file, the same as the one I've used during my data science video in the Jupyter notebook. And in my Scala folder I'm gonna like writing my scripts. So this is like a very basic Spark application. We have the main function where we define our Spark session and its attributes. Then we are defining the path toward the CSV file. Then with the read function, we are reading our CSV file. We're specifying that it contains a header. The format is a CSV file, and please load it. Once it's loaded, it's going to be stored in the data variable as a data frame. Then we can use like functions such as count and show in order to see, for instance, the number of rows in the data frame, and show like a subset of this data frame. So here I already executed my application. So here I'm gonna see like the number of lines, the message that we have here, the print line, then we have the print line of the row count, and finally here is our data frame. With the show function we just get like the top 20 rows. So that's gonna be all for this video. We saw like a very basic application. You can start from here. You can find this code in my GitHub, download it, run it, import it with your IDE and run it, and from there you can start and build your own solutions, your own Spark solution. That's gonna be all for this video. Thank you so much, and see you next time. Ciao.